So we're in my classroom, kind of stuffed this thing in here, didn't we? And this is a 5.3 liter engine, again, Chevy Avalanche. Check engine light is what we're handling. We haven't read the codes. We have no idea where we're going. I thought we could do it together live, and thought processes and all that stuff is important. So first thing we're going to do is go to our codes menu. So go ahead and click on codes menu and display codes. And then what we want to look at now would be DTC display. This menu is a little bit different. All right, so we have some EVAP emission codes, which I wasn't hoping for. And we also have an engine misfire detected, P0300, P0300. Two completely separate issues here. Some of this, for you guys being new at doing this, the 449 and the 455 codes, the EVAP system, that's not going to cause an engine misfire condition. I think maybe the first part of this, because it's not misfiring, although he did complain about a little bit of a rough idle. I didn't feel a miss. He said it runs great, drives great. That one's going to be difficult. It's not going to be something we can pinpoint like a faulty coil or an injector or something along those lines. I think the best thing that we could do right now would be to deal with this 449 code. And for a few reasons. One, we just covered section 3 together, which is output solenoids, transistor, drivers, and controls. This 449 code, vent solenoid control circuit, would be perfect for that. So I think that's what we're going to do. The EVAP system large leak fault is going to be associated with this vent solenoid. I don't know if I can do this on here. Let me see that stylus. Just to give you guys a very, very fast overview of this. What you have on this system is we would have a purge valve that would come back to a charcoal canister. Canister is going to have a vent that would be here, and then it would have a line that comes back to the tank. Okay, so we got vapors in here. Those vapors are collected in the canister, and we pull them in with this purge. Sorry for the poor writing here, purge solenoid. This is a normally closed solenoid. The vent solenoid, which is over here, is normally open, okay? So when the computer does its leak test on these GMs, what it will do is it'll open the purge, commands the purge to open, and it commands the vent to close, and it'll start to pull a vacuum on the tank, and there's a tank pressure sensor that will feed back tank pressure that will feed back that signal to the computer. If we have a vent solenoid here that the computer cannot close, can you understand that when it tries to pull a vacuum on the tank that it cannot, and that it will be pulling atmospheric air in through here, and it will determine that there's a large leak in the system? All right, so that was just a real fast overview of this system. That's why I want to attack the vent solenoid code, this P0449 first. Question so far? Okay. Couple things we can do. Maybe one thing to talk about first would be anytime that you see the word control, the first thing we think about a wiring problem. And when the computer flags control codes, it's generally looking at voltage levels that it doesn't like. Section 3, we talked about output solenoids, and we talked about the output state monitor. You remember that discussion? Voltage is high when the circuit's off on a ground side switch. Voltage is low when the circuit's off on a power side switch. Computer knows that. It's looking at those voltage levels. I believe that code is coming from that. We need to check this vent solenoid to see what our voltage levels are on the solenoid while we're turning it on and off. That's where we're going. It would help to know if this solenoid's power or ground side switched. A wiring diagram would be key here, if you guys remember, or using a voltmeter, checking voltage levels, although when you have a fault that can change things. The other thing that helps is experience. In my experience on every single GM I've worked on, the vent solenoid is ground side switched. So a solenoid that's ground side switched would be, we have a coil of wire. One side goes to the PCM. The driver is in here. This side would be externally powered. You follow? So what we'll have is, if we measure this, 12 volts on the feed, and what we should have is 12 volts on the control until the computer turns that circuit on. As soon as it turns that circuit on, that voltage is going to drop to ground. This is what we're going to check for. We're going to check down here. Similar to the O2 one we just did, Dave, on your car, it's almost identical steps on this vehicle as far as voltage levels go. That's where we're going. Another thing though that we can try to do, which we couldn't do on the O2 because you can't hear a heater turn on, we can go to our functional test menu and we can turn this vent solenoid on and see if we hear a click. That'll give us a guide as to whether or not the circuit's working. So it'll be under output controls and EVAP vent solenoid is what I'm picking. And this is just going to be sound. Now that vent solenoid is going to be back by that rear wheel somewhere is my guess. Let's all try to be quiet for a second and listen. I hear nothing. What about you guys? I'm turning that solenoid on and off. So this one should be pretty easy to deal with. Next step we need to do, guys, we need to find this vent solenoid, do the same thing up here with the scan tool while we're doing voltage checks on that solenoid. Questions? Let's see. Maybe one other thing I can show you. Go to my home tab, go to repair info. This will take me to Mitchell. Depends on our network here today on whether or not this is going to be fruitful. I may skip this. Just want to show you that this is a ground side switch solenoid and how we can do that with the scan tool or with the wiring diagram. All right, so what I'm doing here is I'm doing a quick scan of this first page. That's not it, that's not it. I'm looking for a 2-wire component, guys. Vent solenoid is not on this page. Next page. Possibly this guy right here. See the solenoid symbol is that right there. So let's zoom in on this. Just trying to save a little bit of time is all I'm doing here. EVAP, emission canister vent. We got lucky, didn't we? That didn't take us too long to find it. So we have a white and a red-white wire. Remember that, okay? White and red with a white. What I'm going to do to save time is I'm going to follow this red-white wire. That's this one right here. See if I can highlight that. It should let me stay there. What's this tell us right here about? This is all we need, guys. Right there. What's that tell me about this solenoid? I don't know where the white wire goes yet.
Yeah, spikes.
Red-white wire goes to a fuse, means the white wire has to be what? Ground. And we know the computer controls the solenoid, so where's the white wire go? To the computer. This is ground side switched, just as we thought. So again, going into this, I know a few things about this solenoid that you guys do not. I told you one, this is a normally open solenoid. Means that there should be flow through this solenoid right now. That's the way they sit. Think about it. If you're filling your gas tank and there wasn't a vent that was open, you wouldn't be able to fill your tank. It would keep shutting off. Now it filters it through the canister first, but that's primarily why we keep these vents open. So normally open, that's one aspect. The second one, this is 12 volt feed right here. And this is a switched ground, this white wire. Computer is not turning it on right now, so what should we see on the white wire?
0. No, 12.
Should be 12. Does that make sense?
When I turn it on, it goes 0.
Well, that's right. When we turn it on, it's going to go to 0. All we need to do is 2 voltage measurements. Are we going to double T-pin this?
No.
Are we going to put a T-pin here and a T-pin here and chance these 2 T-pins touching each other? Absolutely not. Never double T-pin a component. We'll do separate measurements with a T-pin, back probing the connector. We just need to find that thing now, right? Now it does give us a little bit of help. It says EVAP canister vent solenoid valve on the EVAP canister. So we find the canister, we find the solenoid. We need to get underneath this truck now. All right, so before we go back and do the solenoid test in the back where we're looking for voltage levels, I wanted to address a question. And Dave had a question, which is a good one. Actually, I'm going to use your wording because it was kind of funny. He said, what would normal people do in a case like this? So I guess I'm abnormal. No, it's cool. It's cool. I totally am. I've been told that. So no, my methods are certainly not what other people's are. I'm sure that's what you meant. I don't want to say they're better. They're just different. I have some different ways of doing things. And you know, you guys have been in my class long enough now know I hate flowchart. So that's everything I do is the anti-flowchart. Anyway, what would a, quote, normal person do with a large leak code? We're laughing here. It is, yeah, we would put a smoke machine on this vehicle and we would check it for a leak. And I don't think I addressed this before, and I think it's important to cover it. The reason we're not doing that is what I'm telling you guys, a solenoid code. This vent solenoid control fault. If the computer, and I did say this, but I don't know if I made it clear. If the computer cannot close the vent solenoid, then it will fail the leak test. So the reason I'm not putting smoke in this system is I want to address the vent solenoid issue, and that will take care of the leak.
Normal people don't know that.
Normal people may not know that. So research would certainly be involved. There's a lot of time you would spend on Mitchell looking at design and things like that, knowing what I've told you already, that this is a normally open solenoid. For a point of reference, that's in section 3, where we cover normally open and normally closed solenoids. So there's a good lecture, a good discussion on that. That's section 3. So does that make sense why we're not smoke testing this? This vent code is going to cause a large leak. Now, once we fix the vent issue, is there a chance there could still be another leak in the system? For sure, for sure. But let's address the vent issue first. Chris, you had a question too. I think your question was, could the leak code cause the solenoid code? Wasn't it that? All right, well look, it's the reverse. It's the reverse. This vent solenoid control code would definitely, if this solenoid is not able to be closed, would definitely cause a large leak fault. You guys need to understand this too, that this solenoid can stick mechanically. The computer's command is there to close it, and it never closes. And the result of that is going to be a large leak.
So like it thinks it's closed.
It thinks it's closed, but it's really not. That is correct. Now this one's a little bit different because we have a fault in the control circuit of that vent solenoid telling us we have a solenoid fault. But I've done many large leak codes that were sticking vent solenoids. In fact, I have a video on that when I make this one, I'll put a link in here, right here, for the other EVAP leak video that I did that addresses that. All right, so back to the solenoid. Let's go do our voltage measurements. And then what we'll do, depending on the result and what we get back there, we're going to use our functional test menu, and we're going to command this vent solenoid to turn on. And that was under output controls, EVAP vent solenoid is what I picked. First thing is, the wiring for this is right here. Can you guys see what I'm pointing at? So this would be the solenoid part, and then there's a filter that sits above here. This would be your vent. The electrical part to control it would be this. Now, looking at this, I don't know how well that's showing up for you guys, but it looks to me like the wiring, it's got some white powder on it, and I know that the camera's not picking that up. So well, there was two things I was thinking of. One is pulling the tape off to do a visual inspection on the wiring, which wouldn't be a bad idea. But I can actually get to the wires no problem to back probe them. So I'll just do 2 voltage measurements and then we'll go from there. The red and white is to the right and the white wire is to the left. So the computer control wire should be on the left. And I'm just using a regular voltmeter. Now the problem that you're going to have in a case like this, we're looking for voltage, right? Is that a yes? All right. So how do we know if I get 0 volts? I'm going to start on this red and white wire to the right, and I'm not damaging this. I'm just back probing in between the wire and the weather pack seal that's in that connector. If I get 0 volts on this, how do I know that that's accurate or that my ground is bad? And I don't have it hooked up yet, but you can see the rust under here, you know, the good old rust belt of Pennsylvania. This is the hard part about doing under car type stuff, especially in the back of the vehicle. We're nowhere near the battery. So the first thing I'm going to do when I take this measurement is I'm going to watch my meter. I think I can show it to you. Can you guys see the numbers on that? Or is that light? How about that angle right there? All right, so when I connect this ground, I'm going to wiggle it and see if I get my 12 volts. I'm just kind of scratching an area with the connector. And I have 11.6 volts in this location. So I did 2 things so far. One is I've definitely identified a good ground under the vehicle. Would you agree? And 2 is I've verified that my supply to this solenoid is good. Now 11.6 is a little bit low, but our battery might be a little bit weak too. We've had the key on for a while. So that's my first one. Second one is going to be just to move my T-pin. I'm actually using a probe that is designed for the tool. It's not really a T-pin, it's a adapter that goes on the end. Pretty cool little tool. Moving that over now to the control wire. This is the computer wire. And I'm measuring 500 millivolts on that wire. So what that tells me is either I have a bad ground again on my meter, so I should probably bounce back over and double check my power feed. Let's do that. Make sure that my meter reads 12. 11.6. So how's my ground on my meter? Good. Come back over here. Measure this. I'm reading 500 millivolts, guys. 0.5. You see it? 0.5 of a volt. It's 500 millivolts. What that's telling me is 2 things. Either the solenoid's being turned on right now, which is most likely not, and I just moved my ground. Did you see that jump around? I bumped my ground by accident. So either my solenoid's being turned on and it has a ground already, or that solenoid is open or has super high resistance. So Bell, you don't have that solenoid on right now, do you?
No.
With the scanner. Can you turn it on for me so I can watch this? You see it drop, guys? Yep. So it looks like the driver's functional. Turn it off. It went to 500. I don't like that 500 millivolts. That's way too low. High resistance for sure. I'm going to show you another method. Can someone hand me, see, I don't know if I can show you the test light version. I'm going to have to rig it somehow. All right, so for this part, I need to use a test light to battery positive, and I need to be careful with what I'm doing. Remember my whole double T-pin thing? Never double T-pin an output? You guys remember that discussion? Okay, well, I'm doing what I told you not to. I am ensuring that this does not touch. It's very important that it doesn't touch the other side. And I'm going to use my red positive lead as my power source for my test light. You follow? And I just adapted my test light. I'll let you guys see what I did. Just being creative with what I have. Took the positive lead off my multimeter, put my black alligator clip so I had one, then I connected my test light to it. You see it? So do you see that my test light's essentially connected to my red white wire, which is up here? You guys understand what I did?
Yeah.
Okay, so does my test light have battery positive on it right now? If I touch a ground, which is a very rusty ground, see my light? What do we want to see on the solenoid control wire when Bell turns the driver on? Hold on, let me touch the pin. Being extra careful that these two pins do not touch each other. Go ahead. Turn the driver off. Hold on, I've slipped off of it. Turn it on. Off. Keep doing that. How's my driver, guys? And how's my wiring all the way back to the solenoid? Okay, let me go back to the voltmeter now. Just so you guys understand, the driver's good. Yeah, you can turn it off. Let's go back to my multimeter. It's another great review of section 3, isn't it? Applying the same thing. You guys don't know anything about EVAP systems yet. We're applying the same information to a solenoid on the EVAP system. Same stuff. There's my 500 millivolts. See it? So understand right now the circuit's off, right? It's ground side switch. Turn it on. Turn it off. Turn it on. Turn it off. Leave it off now. All right. Let's show you the feed side. So you know the feed side's not dropping. And I changed my range, so it's going to look a little bit different. Turn it on. And turn it off. Keep going back and forth. Notice the feed side's not dropping. There is not a supply side problem here. So then why, here's my question to you guys. Why are we reading 500 millivolts? 0.5 on this scale. Still the same. What should we be reading with the circuit off right now? Because right now the circuit's off. Bell, turn the circuit on. There's on. Turn it off. Should be 12. Very good. Why are we not 12? Could we have a wiring problem? Guys, could we have a wiring problem? Before we did any of these checks, could we have a wiring problem? Absolutely. What did we address? There are no wiring problems. So where's our problem? Solenoid. This voltage is very, very, very low. It's basically an open circuit. There is a trickle coming through. There's such high resistance in this solenoid that we're pretty much open. There's just a trace of voltage coming through. If this meter didn't support some type of current flow, I know it's a 10 mega ohm impedance meter, but there is still some trace through this. This would actually potentially still be 12. There's some amount of voltage or current, if you want to call it, that's traveling through this. That's that 500 millivolts right there. It's not completely open.
What if it only had like one strand of wire?
Yeah, one strand of wire, we'd still read a good solenoid. Yeah, it's even worse than that. So I can do a resistance measurement for you guys, and we're gonna have something here. I'm gonna unplug it. Now this could be, this is a really harsh environment, isn't it? And so just so you guys know, I was back probing this, contacting the metal pins inside. So I'm not concerned about the wiring here. This is all good. The connector looks good on this side. The difficult part's going to be to get my meter up here and touch those two and then show you what I'm doing at the same time. I'm not sure I can even do it. What's that, Bell? Yeah, this would be, if I was in the field right now, I charge my garage $70 a car for a diagnosis. That would be, I'm done with this one. And what I would make sure I'd tell that garage owner is, hey, this code is for your large leak code and your solenoid code, not the misfire. Does that make sense? The misfire fault code is completely separate. We didn't even touch that. So whole different ballgame. Now I might also look at, because maybe I only had 5 minutes, 10 minutes into this one, I may continue and go into the misfire fault for them for the same fee. It just depends how long it takes me. I don't have really a set rule for that. That's a good question. If we were to smoke test this in the first place, without going this way, there would be smoke dumping out of the vent valve. Right in this area, we would have smoke pouring out, and that would have pointed us in the direction of the vent solenoid.
You could like command it close and it would stick up.
That's exactly what we're supposed to do. I don't know if that picked up or not, but when you do smoke tests, guys, everybody listen. When you do EVAP smoke tests, your first job is to block off the vent on any car. You have to find the vent and block it off. There's a normally open vent on every car. The vent solenoid is this piece you're looking at. This whole piece. On a GM, block it off. On a GM, what we can do to block it off is we can command it with the scan tool and we close it. So if you're working on a GM, you're doing a smoke test, you connect a scan tool and you close the vent solenoid, then you smoke test it. Every car is different. Some cars don't offer us bi-directional controls, so we have to get in there and manually energize them, or in some cases, as long as they're not plastic lines like this one, in some cases what we can do is we can block the vent line with a pair of vice grips. So I want one on each pin of the solenoid. You can imagine if this solenoid lives in an area where you can't even do this, how much resistance testing sucks. So I'm touching the two pins, hopefully touching the two pins. I expect to have some type of mega ohm reading. That's on my mega ohm scale, and I'm reading OLM ohms. Let's make sure I'm making contact of the pins. Definitely making contact. There you go. Open solenoid. No question about it. Even if this read some decimal point, I was not going to be concerned. Doesn't change our problem. Any questions on the resistance check? Questions on the voltage reading we had? I'm not sure I'm making myself clear on that. Mega ohms is in the millions of ohms. So if you were to say take, let me get a different screen. We have a 12 volt feed going through a solenoid on its way to the computer, and I was reading 11.68 on the feed, and I was reading 0.5 or 500 on the control. solenoid's open, why was this not, right here in this location, a true 0 volt? Now, according to my ohm meter, when I ohmed this, when I ohmed it, I went end to end with the solenoid disconnected. It read OLM ohms, which is an open circuit. I want to know where that trace amount of voltage was coming from. That's what I'm addressing with you guys right now. Where was it coming from? Could have been that ghost voltage we were talking about earlier. I don't think so, though. We were, no, it's definitely possible. That's exactly what we were reading, is from the room, with that solenoid being open. And then when we grounded it with the driver, you know, we're pulling any of that to ground. It could absolutely be that. That's a good point. Another thing it could be is that 500 millivolts could actually be coming from the computer in some type of bias voltage. I thought it was leaking through. I was wrong though. My thought was this, that this solenoid wasn't completely open and that we were bleeding some amount through. And the reason that we are reading that voltage drop, remember guys, I said no current flow, no voltage drop, right? The reason that I was assuming we were reading that 500 is our meter, I mentioned it being 10 mega ohms, would be the equivalent of you connecting a 10 million ohm resistor to ground. So is the meter itself going to cause some type of draw? Yes, but very, very, very small, micro amps, okay? I was thinking that the meter was causing that drop. Either way, we might be overkilling this open solenoid. I just want to address where that 500 millivolts was coming from. Robert mentioned maybe it was ghost voltage. Absolutely could be, because it is an open circuit. But it was pretty steady. Usually ghost voltage jumps around. Let me go back to this and show you one more voltage measurement. I'm just going to back probe the control wire now with it unplugged with my voltmeter again. And check it out. What do we got? 500 millivolts. And if this is ghost voltage, if I shake my leads, hang on, I think all I did there was lose contact. Hold on. I have to be careful not to lose my T-pin connection. And it's bouncing around. That's because I'm moving my ground. All right, if this is what people call ghost voltage, which is picking up voltage from the room, if I shake my leads, I should be able to change that. And I don't know if that's what that is or not. Most likely it is. It could also be a bias voltage that's coming from the computer. In any case, what we know is that was not coming through the solenoid. That's just a trace voltage on the circuit. Whether it be a bias from the computer or picking up outside voltage is irrelevant. Open vent solenoid, no question about it. Our driver is good. Our control circuit is good. Questions? All right, that's pretty much good for this. Again, that's section 3, ground side switch circuit. We tested the solenoid, we tested the driver, we tested the control circuit. Used the test light to confirm the driver. Circuit integrity. A manufacturer flowchart would have you disconnecting the computer, disconnecting the solenoid, and doing resistance checks. You'd be there all day.
So you said the misfire and the lead came from this that way.
No, the misfire is completely separate. Good question. We've just addressed this one and this one. We have not addressed the misfire. So we need to do that next, and this is the only car we're working on today, so we can address the misfire after you guys take a break.